Hello, thanks for tuning in. Geometry, how are you doing? You have tuned in to Unit 8, Lesson 1. I appreciate your time. Let's dive right into it. Area and perimeter. Area and perimeter. Let's review some basic area formulas from good old middle school. Rectangle, length times width, right? Triangle, 1/2 base times height. When it comes to blocks like this, count them, right? And when it comes to a parallelogram, base times height. Let's start with our rectangle, length times width. Length times width here, what's the area? 27, 9 times 3. And what's the perimeter? Perimeter is the distance around the shape. So you've got 9 on this side, 9 on that side, 3 on the right side, 3 on the left side. Add them all together, the total distance around the shape. 9 plus 3 is 12, another 12, 24 inches. For area, your units are square inches or inches squared. You've heard it both ways, right? I mean, like, you've probably heard of like a house having like 2,000 square feet, right? That's the square footage, the area of the house. But sometimes people say like feet squared, right? They like to write it shorthand with feet squared. It really doesn't matter to me. Area of this triangle, 1/2 base times height. Well, half of 6 times 7 is 21. What's the perimeter? Getting cheeky here, right? What's the perimeter? This is a equal... This is a. I think we're supposed to assume that this is a bisector. So we know the base is 7, right? But this is bisecting it, so we know that this is 3.5. Are we supposed to assume equilateral? I don't think so. So if we're trying to solve for this missing side, 6 squared plus 3.5 squared equals h squared, right? For our hypotenuse, we know the legs, but we don't know the hypotenuse. Yeah? So that comes out to be 36 plus, what is 3.5 squared? 3.5 times 3.5 is 12.25 equals h squared. Add the two together. You get 48.25. And then you take the square root and you get... We'll call it 6.9. So if this is 6.9, then this is 6.9. It's super close to being equilateral, meaning all three sides are the same, but honestly not quite. So what's the total perimeter? 6.9 plus 6.9 plus 7 is 20.8. Just count the blocks. Each of these is like 1 square foot, right? Like, what is area? When we say like the area of a house is 200 square feet, which is super tiny. Like an apartment is 500 square feet. That would be like if you had 500 pieces of paper that were 1 foot by 1 foot, like tiles, and put them in the apartment, 500 of them would fit. That's what we mean by 500 square feet. So just count the number of blocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm already miscounting. This is hard. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 50. I counted 50. We don't really have units for this, so I'm just going to say units squared. And then what's the perimeter? You just add the edges. So 4 plus 1, 2, 3, 4, 5. And that's a little 1. And then 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And then a little 1 and a little 1. I'm going to write 2 there because it's kind of hard to write 1 for both of them. And then 2. And then 1, 1, 1. So that's 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, and then 1, 2. You see how I'm just counting along the edges and then adding that up. So 4 plus 5 is 9, plus 1 is 10, 16, 22, 24, 27, 30, 33, 37, 38, 39. So 39 units is the perimeter. A little tedious, I will admit, right? But at least it's not difficult, right? You're just adding all the edges along the shape. And then, finally, it's a fairly easy one. Parallelogram here, base times height. The base is 15. The height is 11. What's 15 times 11? 165. And then what's the perimeter? Same on top and bottom, same on left and right. 15 and 15 make 30. 14 and 14 make 28. 30 plus 28 is 58 millimeters. Okay, that took an obnoxious amount of time to review some classic area and perimeter, but I think we needed it, right? I think we needed it. Get some exposure. Area is the amount of space inside the shape. Perimeter is the outer edges, okay? So recall that blank is the sum of the lengths of all the sides of a polygon. Perimeter. Recall that to find the area of a rectangle is length times width, and a triangle is 1/2 base times height. How does the Pythagorean Theorem help us find the perimeter and area? So here's a random shape, a triangle, plotted on a coordinate plane, right? And there's this box that has been sketched around our shape. This box creates other shapes, right? This box creates other shapes. This triangle, which that's annoying. Let's just do colors, I guess. It creates this triangle, and it creates this triangle, and it creates this triangle. What is so great about those triangles? They are right triangles. This triangle is not a right triangle. I know what to do with right triangles. I use the Pythagorean Theorem. I can solve for anything with right triangles. Some random floating triangle is not as easy to deal with. So that's why we draw this box and we create these right triangles. So how does the Pythagorean Theorem help us find the perimeter and area? See picture here, right? See picture. I'm not going to write some wordy explanation. Just realize these shapes I know how to deal with. This one, I don't. Let's see it in action. Let's see it in action. So as we make a box, we create this triangle. We create that triangle, right? Which we can really do some clever stuff here, can't we? With my iPad. So we create that triangle, right? Let me, like, I don't know, do some shading. So we got that triangle. And then we can create this triangle. Do some shading there. And then we can create this triangle. Maybe not. And again, why is this so useful? Why is this so beneficial? Because they're right triangles. I can see the dimensions of these triangles are 1, 2, 3, 4, 5, 6 across the top there. 6 down the side, 2 for the side of the purple triangle, 1, 2, 3, 4, 5, 6, 7 for that purple triangle on that side of the triangle, 2 there, and 8 tall there. So if I want to find the perimeter of this shape, I know that this side is 3, but I have no clue what these three sides are, the green side, the purple side, and the red side. But I can solve for them. I can solve for them using the Pythagorean theorem. I can solve for them using the Pythagorean theorem. I can solve for them using the Pythagorean theorem. Same thing 3 times over. We've used this so much in our class. So the answer here is the square root of 72, which is 8.5. The answer here is the square root of 64 plus 4 is 68. 8.2. And the last one is the square root of 49 plus 4, which is 53. Square root of 53 is 7.3. So now that we know each of them, we can add them together and find the perimeter. So that plus this plus that, and don't forget the fourth side. And now you have your perimeter. 8.5 plus 8.2 plus 7.3 plus 3 gives us approximately 27. What about area? Well, I can find the area of each of these triangles very easily as well. 1/2 base times height. And because they're right triangles, the base and height is quite obvious. 1/2 6 times 6. 1/2, let me change colors. 1/2 of 2 times 7. And 1/2 of 8 times 2. My answers come out to be 36 times 6 is 36, divided by 2 is 18. 2 times 7 is 14, divided by 2 is 7. 8 times 2 is 16, divided by 2 is 8. What's so beneficial about knowing the area of each of these? This is 18, this is 7, and this is 8. Well, the box, stay with me on this logic here, the box has a dimension of 8 by 8, right? This box is 8 by 8. Or sorry, no it's not. 9 by 9. I apologize. No, it's not. Sorry. 6 plus 2 is 8, and the top side is 9. Okay, sorry. The dimensions of this box are 8 by 9, right? This shape is trapped in a rectangular box that is 8 by 9. The area of the entire box is 72. But we don't want the entire box. We want this like trapezoid looking shape, this weird quadrilateral. Well, subtract away the parts that you don't want. We don't want the green triangle. Subtract it away. We don't want the purple triangle. Subtract it away. We don't want the red triangle. Subtract it away. When you remove those triangles, you're left with the shape that we care about. And 72 minus 18 minus 7 and minus 8 is 39. I'm going to use U for units squared because I don't really have any units on this. I 100% acknowledge that that is a lengthy example. However, it is repetitive. So please, take pleasure in that it is repetitive. Once you know what to do for one triangle, you're just doing the same thing for each of them. But I hope that logic overall makes sense. You can use those triangles to find the edges of the shape, and you can use those triangles to find the area, and you subtract them away to leave you. It's like cutting them off, right? It's like if someone handed you a piece of paper and then they said, hey, cut away some of the stuff. Okay, aka subtract it away. Okay. Building a dog run. So let's kind of put some real life example to this. Building a dog run. And I didn't really ask a single question during that entire example. I kind of got on a roll. So let's have some questions in this second example. Building a dog run. A dog run in your backyard can be modeled by plotting the vertices -2, 2, 0, 5, 4, 3, 4, -4, and -4, 4. -4, -4, sorry. So we have a dog pen that is like kind of a strange shape. Not sure why someone would make their dog pen this shape, but it is what it is. So if we were to draw a box around this, that's the best starting point, is to draw a box around your shape. It thinks I wanted a square. I'm just going to make it obviously not a square and then shape it to what I want. There we go. So when we do this, something strange happens over here in the left. Oh no, it's not what I wanted. Something strange happens over here in the left-hand corner. But can we salvage this? Yes, we can make this triangle, and we can make this box, and then lastly this triangle. And then of course there's this triangle over here, but that one wasn't giving us trouble now, was it? You see my strategy? You see my strategy on how I'm breaking this up? I hope you do. I hope that makes sense. So, fencing costs $16.85 per foot. What is the cost of the fencing for the dog run? So, this is the dog run. Let me bring it back to life a little bit. This is the dog run that I'm bolding here, right? I'm trying not to cover my colors that I created, but this is the dog run, and we're trying to put a fence around it. Here's a question on screen. If you're trying to calculate the cost of fencing, do you need to know the area or the perimeter? Do you need to know the area of the perimeter? You need to know the perimeter, right? Fence is literally like defined as perimeter in a way, right? When someone says scan the perimeter, right? You're going along the edges of the fence, probably, of your property, right? You know, war movies, right? They got like a boundary. Scan the perimeter. It's like a fence, okay? So if we can find the length of the fence in feet, all we're going to do is take the length of the fence and multiply it by the $16.85 per foot, right? For each foot of fence, we must pay $16.85. That's going to be a pricey fence. That's going to be pricey. So, what is the cost? Let's solve for the perimeter. So we need to know this green side. We clearly know that this side is 1, 2, 3, 4, 5, 6, 7, 8 wide, and then 7 tall over there. But we need to know these angled sides. So I'll do 1, right? We've got 1, 2, 3, 4, 5, 6, and 2. So we've got 6 squared plus 2 squared equals c squared. So what does c equal? It equals approximately, what is that, 24 plus 4, so that's 28, so 5.3. So tell me, what's the length of this side right here that I'm super bolding there? Right? What's the length of that side that I'm super bolding there? Here's a few answers on screen. You've got this side, which you can hopefully see as 3. You've got this side, which you can hopefully see as 2. What is the third side? You do 2 squared plus 3 squared equals c squared. 4 plus 9, 2 squared and 3 squared. 4 plus 9 is 13, and the square root of 13 is approximately 3.6. And then lastly, this purple one, 1, 2, 3, 4 wide, 2 tall. So 4 squared plus 2 squared equals c squared. 16 plus 4 is 20. The square root of 20 is 4.5. So the estimated perimeter here is 5.3 plus 3.6 plus 4.5. Those are the edges that we needed to solve for, but that's not the total perimeter. Don't forget to also add the 7 and the 8. And the total perimeter comes out to 28.4, and we multiply that by 16.85 to find the total cost. Comes out to be $478.54. That's a fence, all right. I don't own a house, but I sure as heck wouldn't want to pay $500 for a fence. Video's a little bit longer, but I feel as though we definitely need to see this last example, and then we'll be done. You decide to cover the ground with a rubber mat because it is easier to clean. If the matting costs $3.75 per square foot, how much will it cost to cover the ground? Well, you can guess it, right? If that problem was dealing with perimeter, this problem's dealing with area. So we again want to find the area of this irregular shape, right? Well, I have a bunch of regular shapes that I easily can find the area of. So if I take the box and subtract away all of this crap that I don't need, I'm going to be left with this weird shaped dog fence. Box minus green triangle minus red triangle minus the orange rectangle minus the purple triangle will leave me with my area. Can I leave you to do that? I think area is easier. Why don't you start it with me? Start it in your calculator, start writing it down, because I'm going to ask you what the area is. You can do it along with me, but I'm going to ask you what the area is here at the end. So the box is 8 by 9. And what's the area of triangles? 1/2 base times height. The green triangle is 6 by 2. The red triangle is 3 by 2, 1/2 base times height. A rectangle is just length times width. And the purple triangle, 1/2 base times height. What does that come out to be? What is the area of our dog pen now that we've taken the box and subtracted away each of those shapes? A few answers pop up on screen. I need to punch it into my calculator as well. I got 53. Did I do that right? I think so. Let me check it one more time. Yeah, I got 53 times 375 per square foot, giving us a total cost of $198.75. I appreciate your time. We're just under 25 minutes. I appreciate your time. I'll see you in class, and enjoy the rest of your day, whatever day it is for you. Bye.